Okay, geometry fans, our topic for today, this is notes 8-4. Also, it will be 8-5, and this is trigonometric ratios. Before we start, let me give you your joke of the day. What did the tree say to the wind? Leave me alone. All right, so our goals for today to understand the three basic trigonometric relationships and to use trigonometric ratios to solve right triangles. So first of all, the word trigonometry, the word geometry, we've already talked about this. Geometry means earth, measure. So what we call trig would be the shorthand way. Trigonometry, trig means triangle, and again, metry means measure. So when we are studying trig or trigonometry, we're studying triangle measure, how we measure certain things in triangles. So while trigonometry is something that you might also see in a pre-calculus class, you'll see it up in calculus as well, it is a geometry topic because we are doing measurement. Now, what you're going to learn today is a little phrase. It's not a real word, SOHCAHTOA. Now, we'll come back to that in a second, but to start, we're going to look at this example here. We have a right triangle, and the legs are 3 and 4, and the hypotenuse is 5. Up until this point, there's been no way for us to make an equation that relates side length to angle measure. We're allowed to say that the biggest side is opposite the biggest angle, and we can compare and say angle A has to be bigger than angle B because the opposite length of angle A is bigger than the opposite length of angle B. However, we have not been able to make an equation that relates those until now. So there are 3 words that I'm going to introduce: sine, cosine, tangent. With the sine of an angle, there's an equation that says that the sine of an angle is equal to the opposite length divided by the length of the hypotenuse. The cosine of an angle is equal to the adjacent length divided by the length of the hypotenuse. And the tangent of an angle is equal to the opposite length divided by the length of the adjacent side. Okay, so what does that mean? Well, if I pick an angle, I'm going to say, let's say angle A, okay? Now, based on angle A, the opposite length would be the 4. So I would label that, I'm going to label it op, that's my opposite. The hypotenuse is always across from the 90-degree angle. So this is hypotenuse, HYP, and that means that the other side here, that is the adjacent. So adjacent means next to. Next to angle A, there are 2 sides, but since the 5 is already the hypotenuse, because it's opposite 90, that means this is the adjacent side. So the sine of an angle, if I'm using angle A, I could say, now we abbreviate sine as SIN, so the sine, angle A, it's not sin, it's sine, it would be the opposite length divided by the length of the hypotenuse. The opposite length is 4, and the hypotenuse is 5. So this is a ratio, it's a fraction. This is why we call it trig ratios. The cosine of angle A is the adjacent length divided by the hypotenuse. The adjacent length to angle A is 3. The hypotenuse is again 5. The tangent of an angle, so we abbreviate that tan, the tangent of angle A is the ratio of the opposite length, 4, to the adjacent length, 3. So these names, sine, cosine, tangent, we have words now in equations. Well, what this is referring to, it's the relationship of the angle measure to the appropriate lengths. If I pick 2 random sides here, I could compare 4 and 5, 3 and 5, or 3 and 4. And so one of them is sine, one is cosine, one is tangent. Now the way that we can remember this is a word, or again a made-up word, so, ka, toa. S stands for sine, opposite over hypotenuse. There's your so. The sine is equal to the opposite divided by the hypotenuse. The cosine C is equal to the adjacent length divided by the length of the hypotenuse. So that's AH. Cosine is A divided by H. And then T is tangent. That's O divided by A. Tan is the opposite divided by the adjacent. So, ka, toa. Okay, that's how you can remember this. Now, one thing that's important here is this only works for right triangles. So you have to have a 90-degree angle there. And the other thing is, the angle that we choose is never the 90. We always choose one of the two acute angles. If we had chosen angle B, then things are going to change a little bit. If I had chosen angle B, the opposite length, opposite angle B would have been the 3. So that would become my opposite. The 4 would be the adjacent. The 5 would still be the hypotenuse. Okay, but if I wrote down the sine of angle B, so sine B, the two side lengths would be 3 over 5. Opposite hypotenuse is now 3 over 5. The cosine of angle B, cosine is adjacent over hypotenuse. Well, now the adjacent is 4, the hypotenuse is 5. The tangent of angle B is the opposite divided by the adjacent. Toa, opposite over adjacent. So opposite is 3, adjacent is 4. So you notice that your fractions change. So it's determined, your values, your ratio is determined by the angle that you choose. Okay, so it's important to remember, never choose the right angle, always choose one of the other two. Okay, so let's do an example here. Let's take number 1. Find the sine, cosine, and tangent for angle D. Now, one thing you're going to see me do is I'm going to circle the angle that I'm using. So there's angle D. The opposite, if I draw my arrow, the opposite length would be 12. The adjacent will be the other leg, 5. Now, the hypotenuse right now is blank. Don't forget, in a right triangle, if you're looking for lengths, you can always do a squared plus b squared equals c squared, Pythagorean theorem. So that's what I'm going to do on the side here. 5 squared plus 12 squared equals x squared, and this would be 25 plus 144, which is 169. And then to undo a square, we have to take the square root of both sides. That's actually a perfect square, it's 13. So the hypotenuse is 13. All right, so now we're going to find the sine of angle D, the cosine of angle D, and the tangent of angle D. And again, the way that I like to remember to match it up is so, ka, toa. I'm going to write it here, just so I don't have to keep sliding my paper up and down. Okay, so if we want the sine of angle D, the sine is equal to the opposite divided by the hypotenuse. Opposite is 12, hypotenuse is 13. That's it. That's the ratio. The cosine of an angle is the adjacent divided by hypotenuse. So the cosine of angle D is 5 over 13. And then the tangent of an angle is the opposite divided by the adjacent. So the tangent of angle D, opposite, adjacent, is 12 over 5. And that's it. At this point, we're done. One of the ways that you can kind of remember this, and it's goofy, but if you spell this out, so, ka, toa. If you ever get confused of which letter's going where, just sound it out. So, O, okay, so that's O over H. Ka, that's an A over H. Toa, owa, opposite adjacent, OA. And that is the end of part 1.